Alright, for this video we're going to review stoichiometry. So go ahead and start by taking out your classwork, Stoichiometry Part 1, and turn to the back side. Also, go ahead and take a few seconds and get out your interactive notebooks. Turn to page 12 to your stoichiometry roadmap. It looks like this. Throughout this period, we'll be looking at this roadmap. So before we do any of the stoichiometry problems, I want to make sure that we thoroughly understand this roadmap. The way this roadmap works is it allows us to take any starting material. So if we're in mass, volume, particles, whatever we're starting with, and we can convert it to mass, volume, or particles of another chemical. That's why on the left side we have chemical A, and on the right side we have chemical B. For most of our problems, we will be doing mass conversions from grams of chemical A to mass conversions for grams of chemicals B, so we'll probably not be doing a whole lot of this, if at all. So just make sure that you understand that it still works the same way, but what's important is that you're able to go from grams to grams. So let's say that we want to convert from grams of one chemical into grams of another chemical. Well, each of these arrows right here represents a different step that we have to take, which requires a conversion factor. Okay, and most of our problems, they will be 3 steps. So if we're going from grams of A to grams of B, then it's going to be a 3-step problem. The first step will require us to use molar mass, which we get from the periodic table. The second step uses mole ratios, which we get from the coefficients in a chemical reaction, and the third step uses molar mass. However, a problem doesn't have to be a 3-step problem. We can start with moles of A and convert from moles of B, or we can start with moles of A and convert to mass of B, or we could even start with mass of A and convert to moles of A, mass of A and convert to moles of B. So whatever we want, we can go anywhere on this chart, and that's why we have this roadmap. So it basically shows us what conversion factors we'll be using when we go to that location on the map. So now, getting back to the classwork, I'm going to solve question number 7 for you, and then you will get to do number 8 on your own. So number 7, and before we start this, remember it's important that we know the molar masses of all the chemicals in our equation. Now I gave those to you last time, so if you didn't get those, the first one is 44, and that's grams per mole. Next one is 32 grams per mole, 44 grams per mole, and finally 18 grams per mole. Now I don't want you to get confused. Many people, when they do this problem, they see the 4 out here, and when they do molar mass, they'll multiply 18 times 4. That is wrong, because this 4 is only a coefficient, and when we do molar mass, we are only talking about the actual chemical right there. So the molar mass of water is 18 and not 18 times 4. Now for this problem, I first want you to circle what the question is asking for. So go ahead and take a second to do that. Okay, good. It's asking for grams of CO2. Next, I want you to put a box around what the question gives you that you'll probably need to start with. So go ahead and take a second to do that. Good. So 88 grams of protein is what we're going to start with. So now when we set this problem up, the 88 grams of propane goes in front. So we have 88 grams, and propane is C3H8. Next, on the right-hand side, I want to put the equal sign, and I want to write down the units that we're going to. The units for number 7, we are going to grams of CO2. So over here we put grams of CO2, and now it's just a matter of filling in the steps in between. Next, pull out your molar roadmap and figure out how many steps it's going to take to go from grams of this could be chemical A into grams of chemical B. Go ahead and do that, and then put the lines down for each step that it's going to take. Good. as you know, this is a three-step problem, so that means you are going to have three conversion factors for this problem. Okay, again, using our molar roadmap, our stoichiometry roadmap, we know that the first step is converting grams of C3H8 into moles of C3H8. Now, because we have grams of C3H8 on top, we want to put grams of C3H8 on bottom. And I just told you that according to the roadmap, we want to convert that to moles. Now, we aren't changing the chemical yet. We're still dealing with C3H8, so this should be C3H8 up here. We haven't changed it to a different chemical. All we've done is converted from grams into moles. This is using molar mass, so we know from the periodic table that 1 mole of C3H8 is equal to 44 grams. That's our first conversion factor. Now, if we wanted to, we can technically cross off our units because they do cancel off at this point. And as we can see here, we are now currently dealing with moles of C3H8. So next, as we continue to go, we use our stoichiometry roadmap, and the next step is converting from moles of C3H8 into moles of our second substance. So this is where we use mole ratios from the chemical equation. So as always, we take the unit that's right here, and we're going to write it underneath because we want the unit to cancel off. So we take moles of C3H8 and put it on bottom, and now because we are converting it into CO2, we want to put moles of CO2 on top, and this allows us to convert from one chemical to another. Now we're no longer dealing with C3H8, now we're looking at CO2. Since we're doing mole ratios, now we need to use a coefficient, so we look up at the equation up here. That's where we're going to get the numbers that are going to go in here and in here. So for CO2, the number out front is a 3. That means we're going to put a 3 right here. And for C3H8, the number is a 1. So we are going to put a 1 right out here. And at this point, we have now converted it to moles of CO2, and we can look at our units, and those units can now cancel each other off. Alright, we go back to our molar roadmap. Our final step is converting it from moles of CO2 into grams of CO2. So we put moles of CO2 down here. Again, we put it down here so it can cancel off with this one over here. And then we don't want moles, we want grams, so we put grams on top. And you notice the units that are on top here are equal to the units that are in the answer. So our units should always match up in that way. So now we use molar mass. We know that 1 mole of CO2 is equal to 44 grams of CO2. Okay. Now we've set up the problem. We can cancel off the last of our units, and we are now left with grams of CO2. And so the setup for our problem is now complete. Okay. Before we finish and do the math, there are two things I want to point out for this. One, when we look over here, on the left side and on the right side, these two conversion factors are from the molar mass. Notice what number on each of these is always before the mole. It's a 1. You would never have a different number before the mole when you're dealing with molar mass. Molar mass is always with regards to 1 mole of that compound. The only time you have a different number in front of the molar mass is when you're dealing with the mole ratios in the middle. And that's because these numbers right here from the mole ratio come from the coefficients in our original balanced chemical reaction. Now, in order to do the math for this problem, I'm going to wipe the board clean, and then I'm just going to show you the numbers without the units so we don't get confused by the units. So go ahead and take a second, finish copying this down if you need to, and then we're going to move on and do the math and actually solve these numbers. So without the units, this is what our problem looks like. And we know that since the 88 is by itself, we actually know that that's over 1. So basically what we're doing is multiplying all the numbers on top and dividing it by all the numbers on bottom. Looking at this, though, I can see one easy math step that's going to help in solving this. I see a 44 up on top, 44 on bottom. I can cancel those off. Now this problem is simply just 88 times 3. 88 times 3 gives us 264, and that's our answer to this problem. So now that we go back with the units, our answer here is 264 grams of CO2. So what this means is that if we have 88 grams of C3H8, according to this balanced chemical equation, I can make 264 grams of carbon dioxide, and that is stoichiometry. Now, for problem number 8, I'm going to set it up for you, and then I'm going to give you 2 minutes to work on this by yourself, or actually I'll let you work on it with your partner. So as soon as I set this up, I'm going to have the sub pause it. You'll work on it for 2 minutes, and then you'll check your answer with mine. So for setup, first we have 96 grams of oxygen. Sorry, that's supposed to be boxed. So we put a box around that. That's what we're starting with. And then it's asking for grams of O2. So when we set this problem up, we put 96 grams of O2 over here. We are wanting grams of H2O, and we know that this is a grams to grams problem, so that means it's going to be 3 steps. If we didn't know that, you could just check your stoichiometry roadmap and know that. So that means we need to plug in our 3 steps for this problem. Okay, now that this problem is set up, I'm going to go ahead and have the sub pause the video so that you can complete this for 2 minutes, and after 2 minutes, the sub can resume the video so that you can check the answers. Okay, your 2 minutes are up, so go ahead and check your answers with or on the screen. When you've completed this problem, your answer should be 43.2 grams of H2O. Okay, now that you've solved number 8 on your own, I want you to do, with your partner, I want you to do numbers 9, 10, and 11. Go ahead and finish this worksheet, and then while you're working on this, if you do need to look at your answers and check them, I will have a cue for the sub. The sub can leave them up on the front lab table. So remember, you are allowed to go check your answers, but you do not get to take a pencil or pen to write anything down. You cannot take any pictures. All you get to do is go look and see how it was set up, what the answer was, etc. But you cannot remove the paper, and you cannot take anything up there to write or take pictures of it. So good luck. If you need any help, make sure you ask your neighbor. Your neighbor should be the first person you go to. If your neighbor doesn't know, then ask the people either behind you or in front of you. And then if you still have questions, then make sure you let me know on Edmodo after class, and I could be sure to address them when I get back next class. All right, good luck, and I will see you soon.